Here, the first initial value problem we want to solve is y prime equals cosine of pi x given the initial condition y of 1/2 is equal to 2. So an initial value problem is really just a differential equation with an initial condition. If I have y prime is equal to cosine of pi x, to solve for y, I'm going to need to integrate. So y is the integral of cosine of pi x dx. So here, the antiderivative is going to be 1 over pi sine of pi x plus c. So this is my general solution to the differential equation. Because I have an initial condition, I can solve for the specific value of c. So when I substitute in 1/2 into x, what comes out should be 2. So off to the right here, I'm going to say 2 is the output when I substitute in 1/2 into x. So that would make the inside here pi over 2. And I'm solving for the c value. Well, sine of pi over 2 is equal to 1. So I have 2 is equal to 1 over pi plus c. So subtract 1 over pi. 2 minus 1 over pi is equal to c. Now c isn't the solution. The solution is the entire equation. So my solution is y equals 1 over pi sine of pi x plus 2 minus 1 over pi. Now let's solve the second derivative of y with respect to x is equal to 2x minus 5, given the two initial conditions, y of 0 equals 2 and y prime of 1 is equal to 1. So here we have a differential equation that involves a second derivative. So we are interested in finding the original function y. So we're going to need to integrate twice. So another way to rewrite this is to think about this as y double prime is equal to 2x minus 5. So we're going to have to integrate once to get y prime. Y prime is the integral of 2x minus 5 dx. So if we integrate 2x minus 5, we're going to get x squared minus 5x plus c is equal to y prime. Now, I can solve for the value of c because I have an initial condition involving y prime. When I substitute in 1 into each x, what should come out is 1. So we'll pull that work off to the side. 1 is the output and 1 is the input. So 1 squared minus 5 times 1 plus c. So I have 1 is equal to 1 minus 5 is negative 4 plus c. So add the 4 to the other side, we get 5 is equal to c. So I'm going to substitute that 5 in for c and have y prime is equal to x squared minus 5x plus 5. Now, we want to get all the way back to y, so I need to integrate again. So now I know that y is the integral of x squared minus 5x plus 5 dx. So y is equal to x cubed over 3 minus 5x squared over 2 plus 5x plus, we'll use another constant since c was already used in this problem. Let's call it the constant d. So now we can solve for d because we have an initial condition involving the y function. When we substitute in 0 into each x, what should come out is 2. So if I go ahead and do that, I can almost do that mentally, but I'll kind of show what's going on. So 2 is equal to, we're going to have 0 minus 0 plus 0 plus d. So d is equal to 2. And so now I can substitute that 2 back in for my final answer. So my final answer is the equation x cubed over 3 minus 5 halves x squared plus 5x plus 2.